Alright, this is lesson 56 for Algebra 1. Today we're continuing our statistics unit in algebra, and we're talking about representative functions. So we have scatterplots. We gain data for scatterplots, and scatterplots is when we compare two different things to each other. We'll say like gas mileage versus engine size, or we might say hours of sleep to GPA, or we might say hours of study per night and GPA. So we compare them, and we use scatter plots to see, are they related? Okay, is there a correlation between two things? Do you guys think there's a correlationship between hours of studying and your GPA? Yeah, don't you think that the more you study, the higher your grades are, right? And we could prove that with a scatter plot. And the other question, make sure your phones are off, okay? I don't think that was me. Whoever it was, you know it was. Turn it off. Just turn it off, okay? I don't know it wasn't you. Okay? It's alright, just turn them off, please. So looking here, shh. Two things could be correlated, like the more you study, the higher grades are. We know that there's a correlationship. Do you think studying more causes higher grades too? Yeah. Do you all agree that the more you study, it causes higher grades? Don't you think that's true? Yeah, we know that's true, right? Here's another thing. Let's say we compared shoe size to your reading ability. Okay?
That makes no sense.
Well, let's think about it. Let's say you had small shoes. Let's say you're a little baby. Size, what, 1 shoe? What do you think your reading ability is as a baby? Really low, right? Okay? You're all, bigger now. You're all older. So you have a size 9. Don't you think your reading level is high school now? So it's true. Didn't I just prove my point? The bigger your shoe, the higher your reading ability. Is that true? So isn't there a correlationship? Don't you agree? Right? Because if you're a baby, you have a lower reading level, and then when you become an adult, you get a higher reading level. Do you all agree with me? Okay, now the question is, does a bigger shoe cause better reading? No, because sometimes you could have the biggest shoe in the world and you might not be the best reader. Does that make sense? So there is a correlationship, but that's not a cause of it. So there's a difference there, right? So, because if I thought that was true, and let's say I was a scientist and I said, hey, bigger shoes cause better reading, you all need bigger feet. I'm going to grow your feet, and I'm going to just take your feet, and you need to put on a device, and we're going to stretch your foot, right? Doesn't that sound like torture, right? We wouldn't want to do that. Okay, anyways, there is a difference between correlationship and causation. All right, so here are the steps for today. We're going to be identifying any shapes and predicted direction. Identify if there's a correlationship between the two subjects being compared, and if so, if we want to think if one subject causes the other, okay? So here we go, number 1. We're comparing at the bottom on number 1, hours of study per night to your GPA. Clearly, we know that the less you study, so the less you study, the lower your GPA, right? Do you all agree? And the more you study, the higher your GPA. Do you agree with that? That's what the data says. Let's say this is a set of data I picked all the students I have, and I checked how many hours a night do you study, and people said, oh, this many hours, and this is my GPA. And I took all my students. I have low students and high students, right? This is just the data. Is it right or wrong? No, it's just what it is. But does it prove that the more I study, the higher my GPA? Yeah, okay. And on this one, I could see that there's like a line that I could put in. This is called the line of best fit. And it clearly goes from bottom to top, right? Do y'all see that? It all the dots kind of clump together. Do y'all see that? So we call this a linear line of best fit. And I would identify it and write it down. Okay? That's for number 1. So what did I just do? I looked at what we're comparing. We compared hours of studying to GPA. I noticed that all my dots clumped together as a nice line, and I drew a line, because that's what I noticed, it's a line. And then I wrote, it's a linear line of best fit, okay? That's number one. That's all you're doing is identifying, is it a line, quadratic, or exponential, okay? Number two, here's some data. I wanted to compare shoe size with reading ability, okay? So if you have small shoe size, look over here, small shoe size, you have low reading ability. If you have higher shoe size, it goes up to higher ability, okay? Does that make sense so far? Yes or no? Yeah. Okay. I'm noticing that my dots are clumping together, but are they clumping together as a straight line? Or are they clumping together as a curve? What do you think? Is it a straight line or more of a curve on this one, number two? And more of a curve, right? So I would draw a line of best fit that's curved this way, okay? And to me, this looks like what kind of graph? Is it linear, quadratic, or exponential? It's exponential, okay? So I would say it's an exponential line of best fit. Okay? Now, why is this important to know? It's because when we deal with real data, that needs to be off. You can get on test. When we have real data, we can make predictions, right? We could say, well, it's true. If you have low hours of study, then I could predict that it's linearly related. That if you study 2 hours a night, then your GPA will be 3. If you study 4 hours a night, your GPA will be 4.0. Okay? Over here, we know that if you're a little kid, you have size 1 shoe, you're going to have no reading ability because you're probably a baby. And then all of a sudden, your reading ability exponentially grows as you grow up. In first grade, you might have a size 4. Your reading ability, still kind of low, right? Mm-hmm. And then all of a sudden, you're growing a lot more quickly. You might have a size 7. You might be in 2nd grade or 3rd grade. But your reading ability is doubled, right? Because it's exponentially growing. Does that make sense so far? Yeah. Okay, so that's why we want to identify the type of line we have. This is an exponential line of best fit. Okay, so turn to your neighbor, describe what we're doing. Number 1 solid 2 is about number 1, 2 solid 1 is about number 2. Ready, set, go. Okay, so next one, number 3. Okay, now if I were to ask a bunch of people in their life, I want to compare their age to spending, okay? So when you're really young, let's say you're 5 years old, how much money do you spend? Let's be honest, how much money do you spend as a 5-year-old or 4-year-old? Nothing. You don't buy anything. Does that make sense? Do you spend anything? No. Okay? And then if you're in high school, like you're 15, do you spend a lot? Yeah. You're getting there. Probably not. You probably spend very little, okay? And then you become an adult. And then when you're middle-aged as an adult, you have a lot of money. So you spend a lot. You probably have kids, you have family, right? Do you spend a lot? Your parents spend a lot of money, probably? Yeah. Yeah, they do. And then when you get older, what happens when you get older? Do you keep your job, or what do you usually decide to do? Retire, right? So when you retire, do you have a lot of money coming in, or no? Yes. And your kids are... Probably not. You probably don't have as much money. So do you spend a lot when you're retired? Probably at first you do, and then you get less. So looking at this graph, is it linear, quadratic, or exponential? Quadratic, right? We could see that there's like a line that looks like, draw it, right? We could see that there's a vertex or a high point of where your spending's the highest. We could clearly see that when you're younger, you don't spend a lot. And what happens when you get really old? Are you able to move around a lot? No. Some people aren't. And if you can't move, do you spend money? No, your kids start spending the money for you. Okay? Like if you have an old grandma or grandpa, it's like you have to take care of them, right? So if they're being taken care of, they're probably not spending money. Their kids are probably spending the money for them. Okay? So that's quadratic. So let's write this down. This would be a quadratic line of best fit. Okay? So how could we apply this example to real life? What if you were talking to someone who was in their 20s and you're comparing them to yourself? Can you make a prediction on how much money they spend? Do you think they spend more than you or less than you? Do you think they spend as much as your parents, though? No. No. they don't. Even though they spend more than you, they're not going to spend as much as your parents because they don't make as much as your parents, and they don't have as many responsibilities as your parents. They're not like buying, or they don't have to pay for a house mortgage or like kids' college tuition and all that, okay? Next one, number 4. Let's say I was talking about, I wanted to compare, let's say I did a survey throughout the day from the same amount of kids, and I wanted to compare the time of day with how tired you are, okay? Okay, so I talked to all the kids throughout the day, and during, before school, these kids are not tired, they're like awake, okay? They're already walked to school or they're driven to school. And then at first period, they're still pretty good. Second period, it's starting to go down. And then after lunch, you could tell it's really bad. And then at 7th period, down here, their tiredness is, they have low, well, I guess it's the opposite. It would be not tiredness, but the amount of energy they have. So what do you see about this? Is this quadratic or exponential or linear? You think it's exponential? Okay, good. Yeah, it is exponential. I would even suggest that this is quadratic also, because technically we could have a point on the other side, right? Yeah. What happens before school starts? You're in bed usually, and your tiredness you get your energy back, okay? So I would say this is quadratic. I don't think it's exponential. Okay? Quadratic line of best fit. Or okay, next one. Okay, why don't you do number 5 by yourself? This one is, I took a survey. I wanted to compare how long people are in the sun to the number of moles they had, okay? So, let's say I was a scientist, I was a medical student, and I had patients as a practice, okay, and I asked, hey, how long are you in the sun usually most days, or during the day? And people could have been not in the sun at all, they're in an office, or the people could have been like in the sun all day, they might be like a construction worker, okay? So I asked, can you, and then I physically checked their body, and I said, hey, how many moles you had? And I checked, because I'm a doctor, I'm a medical student, so I wanted to make sure. So what can you tell me about this data? And turn your neighbor, is it linear, quadratic, or exponential?
I don't know.
Okay. So back to number 5 here. What do you think it is? Is it linear, quadratic, or exponential? What do you guys and girls all think? Okay, it's linear, right? I can make a line of best fit like so, with a line going through the data like so, right? So it's a linear line of best fit. Okay. Last one. I did another survey. I asked people in the parking lot. I said, hey, I asked all the teachers that go to work here, and some of the kids. I say, hey, what kind of car do you got? What's the engine size? And how many miles per gallon do you get? Okay. I asked each person, and I want to see if they're correlated. Okay. So talk to your neighbor. Tell me, is it linear, quadratic, or exponential? Go.
Straight or not though.
Okay, what do you guys all think? Is it linear? Raise your hand if you think it's linear. Raise your hand if you think it's quadratic. Raise your hand if you think it's exponential. Okay, so on this particular one, it's pretty linear. I made the graph pretty linear on this one. But if you could have said it's quadratic too, because it's kind of like going slowly down. But I would suggest it's probably more linear than quadratic, okay? Now in real life, the data isn't always like perfect. It could go like this. It could be, it could show a different pattern. So we're keeping it pretty much the same. So In statistics 2, we do use mainly lines, and we call it a line of best fit, where I talk about standard deviation and regression. Okay. Now that was the first part of the lesson. Let's go back to each example, and we're going to ask ourselves: are they correlated, and if so, does one thing cause the other? Okay. Looking at number 1 now. Hours of studying per night and GPA. Are these two things correlated? Is there a correlation between studying and GPA?
Yes.
Yeah, so we would say there is a correlation, and since the line is going up, we would say this is a positive correlation. Okay, now I got a question for you. Now we want to ask ourselves, does studying cause higher grades? Is that true? Does studying cause higher grades? Yeah, of course. So we'd say there is causation, okay? And we would say causation, we would say studying causes, and we would explicitly write causes, higher grades. Okay, looking at this next one. Okay, shoe size and reading ability. Okay, is there a correlation between shoe size and reading ability? Are they correlated?
No.
Does a little kid have a little bit of reading ability, and a big adult have a higher reading ability? So I would say there is correlationship. There is a correlationship. So I would say there is a positive correlation also, because the bigger your shoe size, the bigger your reading ability, right?
That's really real.
Yeah, think about it. Does a little baby who has a size 1 shoe have any reading ability? No. And does a high school student like yourself with a size 7, 8, or 9 shoe have a better reading ability? Yeah. Now, I got a question now. Causation. Does a bigger shoe cause better reading ability? Yes or no?
No.
No. Does that make sense? It does not. Okay, so we would say no causation here. Okay, so that's twice. Give me your phone. Continuing, let's go back to number 3. Is there a correlation between age and how much you spend? I would say no, because it's not directly related. Like, the higher your age, is it the higher the age, the more you spend? Yes or no? At first, yes, but later, no. Okay? So I don't think it is directly correlated. So we're going to say no correlation. There is no causation, right? There is no correlation, because honestly, couldn't you be? Does it really matter, or doesn't it matter where you come from, how much you spend, right? Couldn't you be a high school student that's from a royal family or like a very rich family and spend a lot? And couldn't you be like from maybe a poor family, a high school student from a poor family, and spend very little or nothing at all? Does that make sense? So I would say there's no correlation, okay? How about number 4? Level of tiredness and time of day and tiredness. Is there a correlation here? Earlier in the day you were less tired. Later in the day you're more tired. Yeah. Is there a relationship to that? No, I don't think there is, because even though this is what the data shows, we're noticing that, you could have someone who's tired in the morning. So I would say there's no correlation. Okay, almost done. Next one. Number 5. Oh, I'm sorry. Let me go back here. Number 5. Okay. Turn to your neighbor. Tell them, is there a correlation between sun exposure and number of moles you have? Yes or no?
Yes.
Yes.
Yeah, there is. So we would say it's a positive correlationship because the more you have, or positively correlated, because the more sun you have, the more moles you're going to get. Okay, now does sun exposure cause moles? Let's think about that. Does high sun exposure cause more moles? Let's think about that. Yes or no? I think yes, okay? I think yes, because, and there's actually studies done on that. They took like a picture of people's faces when they're young, and they take it with a UV camera. I don't know if you've ever seen a UV camera. You could Google it. Okay? And they'll take a picture of your face, and there are hidden moles on your face as you get older. Like you might not see them, but they're under your skin, and a UV camera could pull those out. Okay? And they take pictures of people who protect themselves from the sun, or babies that have no sun exposure, and their faces don't have any hidden moles. Okay? So there is a causation. So we would say that sun exposure causes moles. Okay, next one. Last one. Is there a relationship between the size of your engine and miles per gallon? Yes or no?
Yes.
Yeah. Okay, is it positive or negative? Negative. And we're going to call not negative, we're going to say this is an indirect relationship, okay? Meaning the bigger the engine size, the smaller the gas mileage. Right? The smaller the engine size, the bigger the gas mileage. Okay? Is there a causation? Does a bigger engine cause less gas mileage? Is there causation? Does a bigger engine cause less gas mileage? Does it cause less gas mileage? Yes or no? I think so, yes. Doesn't it take more gas to turn a bigger engine? Yeah. So I would say there is a bigger engine. A bigger engine causes less gas mileage. Okay. That's it. All right, so that concludes our lesson for today. Please turn off your iPads or anything you've used.